And pretty quick, I got this. No, of course not. I got this. So it's pretty incrementally hacked up. But you can get the Hackaday page. You can do a web search, Wikipedia. That is odd. Right, so what's that? It's not very fast because it's actually the decryption of the transport layer takes. It's quite a heavy load, but the S3 has some special instructions for that. Keep it in the wrong part if I can show you. Hackaday. And it tells you, it gives you a load indication because otherwise you go, is anything happening at all? And probably not because the web, oh there we go. Oh, 80 kilobytes. There you go. And you can scroll, sorry, I have done a video since here, and you can see that in my repo, which I'll tell you about at the end. So you can, and you can get pictures. If you tap on the picture, it loads eventually a larger one. The pictures are a cheat because you can't really expect to load a picture directly. It might be megabytes or megabytes, so it gets it through a proxy on my web server, which resizes it for it. Next, oh yes, not on me. It's over there. Right, so a really shitty cyberdeck. So I thought I'll spin that out. It'd be nice to have MicroPython. So again, another one of these mini wireless keyboards. Where nicely there's a touchpad, you can put a display. So that's what it looks like. So you can write Python programs and download them similar to the cyberdeck. It has an SAO, but spot the schoolboy error. It's the wrong gender. So I'll change that when I get home. Right, so that's it, half built, with bits of the keyboard, the membrane cut out, then I'd be covering up the holes. Oh, can we get back? Where is back? There we go. So yeah, there's very sophisticated bits of black cardboard. Yeah, I'm getting there, hurry up. So, word about this is all done with vibe coding. So if you're the kind of person who thinks people who use Claude code everything should be set on fire and thrown in the river, if you're lazy, impatient, and don't want to know what the hell is going on, it's for you. Thank you, that's my repo.
All right, we officially end at 3:30, but they're going to let us be in the building until 4. But at 4, we really got to run out. We're going to do 2 more as fast as we possibly can, and then Zoom. But then you're going to just like zoom out of the building. We can chill out and hang out outside in the courtyard. Nobody's going to throw us out of open. No one's going to throw us out of nature. Yeah, it's going to be plugged in, and I have to restart.
Yeah, okay, I'm up. So hi, just as a brief introduction to myself, I'm Terrence, and I'm basically going to try to keep it short. I basically made SDR badge. I made it for. I'm from Singapore, so I made it for DevCon Singapore, and I'm just going to briefly go through why I made it and then what's the process of making it. Yes. So what it mainly can do is that it's basically like an FM radio, so it does local FM demodulation. The batch itself supports from about 7 megahertz to about 300 megahertz, and then of course it has a screen. You probably can't see it here, but you can connect it to a computer and you can receive the signals through our web app or GNU radio. So this is how it looks like. The main idea behind the artwork is that we can overlay out things like the audio waveform and the frequency on top of the artwork, which was something that I thought would look quite nice. And yeah, this is another one of the artwork. Behind the badge, we do have a local audio jack. We have an SMA connector, USB, and it supports a LiPo battery. This is one of the prototypes. There's more features on this one here. You can come over and take a look. So the rough way it works is that first we have an SMA antenna. It connects to this BGA2817 amplifier. It amplifies the signals. Afterwards, it uses the Emacs string that I guess a lot of people know about to basically get IQ samples. Afterwards, we have an ADC. It has about, I think, a 200 kilohertz bandwidth. And we also use this CH32305 MCU. It's a RISC-V chip. I think it's quite popular with some people around here. And it supports USB 2, which is the main reason why we used it. And of course, it's also cheap. It's about $150 US. Yeah. So I drew some of the artwork. This was my first RF project, so I did some RF routing. It's not exactly too high speed, so it wasn't too hard to learn from. I think I watched a video on how the HackRF guy did it, and I basically used some guidelines towards that, especially regards to PCB stack up. Keep the traces short, try to separate the analog ground planes and the digital ground planes, so on and so forth. So this is my first RF project. This is a warning that I don't exactly know what's exactly going on fully here. I worked on this with a friend. The reason I don't exactly know what is going on is that this is my experience working on this project. I was just wondering why some parts weren't working, while my friend who was working on it was basically solving some of the most random bugs that I could have never figured to solve on my own. And of course, we used a lot of AI for this. A lot of this was live coded. Okay, so I think my friend did some schematic magic that I'm not too sure about. You can feel free to ask me about it. Our software stack is that this CH32305 chip supports the standard TinyUSB vendor endpoint. To display the waterfall and the FFT spectrum, we can use this that library for RISC-V. It supports things like FFT. If you've done FFT on the STM32, it's basically that, but for RISC-V. Afterwards, we use some of the screen's hardware scrolling features to enable us to display the waterfall effectively. Yeah, and we have all this running concurrently on the board. This thing was heavily vibe coded, but in some cases I vibed too much that I forgot that I asked it, why is this IQ samples coming out so slowly? And then afterwards I realized that the AI forgot to make it use the DMA to get out the IQ samples, and that took me 5 hours. So I clearly shut off my brain too much. Another big issue on debugging this was that sometimes when I reset the board various times, sometimes the signal shows up, sometimes the signal doesn't show up. Eventually, we realized that our I2S packets weren't aligned properly, so they were a bit slipped or a bit shifted by a certain amount, and you can see from this diagram here. Sometimes you get this very funny looking waterfall diagram where basically it overflowed, it basically gets a bit shifted until it returns back to 0, and you can't really get a proper waveform. This was super annoying to debug because I wasn't sure whether my place had an RF signal, whether it's my board that's having the issue, or whether the firmware has the issue. So that was very annoying to debug. And the way we basically solved this is that we basically spammed the reset button of the I2S ADC until somehow, by some statistic metric, it basically should be working most of the time. And from the looks of the results, it should be working most of the time, yes. So I think my friends did IQ calibration on this thing. So we used, in some metric, we used the system clock to try to do IQ calibration on it because it's stronger, and apparently it led to quite decent results. And of course, this is actually a version 2 of the board. The version 1 of the board, we did some stupid things like our reset button actually just shorts power to ground. Our FPC connector was, I think, face up instead of face bottom. And so we couldn't even connect our screen properly. So that was a good fair bit of prototypes wasted. And after that, since I made this board and I was helping do a CTF, and I was helping to do a CTF at the same time, I repurposed this board for a CTF challenge at my exchange university in Switzerland. Yeah, and yeah, so that's it for this board. I do make other badges also. If you see the ones on the table that look something like this, and you're interested in knowing how they come about, feel free to find me. If you're not interested about this badge, if you're interested to maybe get one or trade for one, feel free to come and find me also. And yeah, I model a lot, but I had a lot of fun. Thank you very much.
Thank you. One more real quick, and then I'll have a quick closing note.